An effective oil separation system during the surface pretreatment process has these three main benefits. One, the life of the degrease chemicals increase, and hence the costs of these degrease chemicals reduce. Two, the discarding frequency increases, and hence the discarding cost reduce. But three, the biggest saving is that it avoids the rejects due to adhesion failure of paints or surface coating process. If you want to know the details of how our Mega Coalescer removes the oil effectively from the degrease chemicals, please watch this video till the end. So we are making these Mega Coalescers in collaboration with many of our customers which handle these or take these big projects to install the entire paint shop. So this system is also going to one of these paint shop project handlers. We also install these systems directly at end consumers or end customers. The system that you see right now is completely made out of SS304. And the total capacity of this system is minimum 100 liters per minute of suction rate, and maximum it can go up to 200 or 300 liters per minute of suction rate as well. The overall dimensions of this system are 1.8 meters in length, 850 mm in width, and 1.35 meters in height. The main application for which these kind of Mega Coalescers are used is to remove tramp oil or floating oil from huge tanks. So tanks which are more than 10,000 liters up to 50,000 liters. So these systems are made for that particular application. Now these floats are connected to air-operated diaphragm pumps. The reason why we suggest using air-operated diaphragm pumps is that there is no risk of the pumps running dry, because even if the fluid level in the tank goes beyond the reach of the floats, even then the pump will not get damaged. Second, these pumps we get in polypropylene material or SS304 material, which are compatible with the alkaline nature of the degrease chemicals they handle. And third, overall increases the efficiency of the system, because in standard centrifugal pumps, the pumped liquid, it is churned, it is agitated before it is pumped. So the liquids, that is oil and the degrease chemicals, which we are separating in this system, we are mixing them together or trying to mix together in the pump. So these air-operated diaphragm pumps, they just push the liquid which is to be pumped. So there is no churning or there is no agitation. So after the suction, the oily solution enters the first chamber. Now this chamber is just to reduce the velocity of the incoming flow. Once this chamber is filled, the oily solution overflows onto the next chamber. Now this chamber has heaters in it. Now the reason why we use heaters is that the degrease chemicals used for this particular application, they leave oil at elevated temperatures. Generally, the incoming temperature of the incoming solution is around 60 degrees centigrade. We use around 18 kilowatt heaters in this system to raise the temperature to about 80-85 degrees centigrade. Now once the solution passes over the heaters, then it enters the chamber where we place Frp plates. Now these Frp plates are there for two reasons. One, Frp holds on to the oil for some time. Second, Frp is compatible with the alkaline hot liquid that passes through it. And third, it sort of provides an obstruction for any slurry or solids that may come in the liquid along with the degrease chemical. Now, once the solution passes through the FRP plates, then it enters the chamber where there is what we call a coalescing material. Now, the principle of this unit is based on coalescence. In coalescence, we force two droplets of a liquid to come together to form a bigger droplet, which becomes easier to separate out. In this case, we force two oil droplets to come together and form a bigger oil droplet, which then floats on top of, or rather it helps in floating on top of the degrease chemical. So once installed, the coalescing material does not need to be changed because it is only providing mechanical separation and not chemical separation. So it does not get consumed and you don't need to service it at all. We, as a maintenance or a preventive maintenance, we do suggest to clean that chamber once a while, but the procedure is very simple. We just pour some hot liquid, some hot water in the opposite direction, and whatever dirt or oil that is sticking to this coalescing material, that is just flushed out. After the coalescing material, we see a very good thick layer of oil being formed near the overflow viers. Now the overflow viers allow the top layer to pass on to the next chamber. The liquid along with the oil passing from the first chamber enters the second chamber, where again we see overflow viers. The same process repeats in the second chamber, and when the fluid overflows in the third chamber, it is about 97 to 98% oil, which can be removed using the oil drain. Now, as you can see, in the first and the second chamber, we have provided two square tubes. Now, these square tubes are open from the bottom. The heavier fluid, in this case the degrease chemical, it enters the square tube from the bottom, and oil-free solution comes out from this outlet, which goes back to the degrease chemical tank. The same process happens in the second chamber. So whatever fluid that goes out from this outlet has absolutely no oil in it, or maybe some traces of oil in it. This is a level sensor which controls the heaters. The level sensor performs the following function. If for any reason the fluid level inside the unit goes down and the heaters are exposed, it immediately cuts off the electrical supply to the heaters and the heaters turn off. So this is for the heater protection. Again, we provide a temperature sensor. So we can set the minimum and the maximum temperature on the temperature controller, and once those are achieved, either the heaters are cut off or heaters are started again. Now we will see how this entire system works together. Now, for the sake of this video, we are simulating the on-site conditions by taking water inside a tank. Now let's imagine that this is the degrease tank, in which this is the degrease chemical, on top of which we have deliberately put some oil. Now as the pump starts, as you can see, the top layer of oil and the degrease chemical is being sucked through the float from both the floats simultaneously. Now once the oily solution is sucked from the float, the oily solution is pumped inside the first chamber. As you can see, a good layer of oil is formed on top of the surface. Then it flows over the heaters, where the solution leaves the oil droplets are left from the solution, and again that starts floating on top of the solution. This entire area is the first chamber. Now, as you can see, the top layer is completely oil, and it is being overflown from first chamber to the next chamber. This chamber is what we call the second chamber. Over here, we increase the concentration of oil even further, And when whatever overflows from the second to the third chamber is almost 97 to 98% oil. So the fluid that you see over here is about 98% oil, which is separated out from the degrease chemical, while the oil-free degrease chemical is being taken out from these two square tubes or square pipes through the outlet and back to the degrease tank. Now, the only preventive maintenance activity needed for this unit is to drain out the entire unit at least twice in a year. To help you drain out the unit, we have connected all the chambers to a central header. By simply opening the ball valve after the header, after the chamber, all the liquid from that chamber will be drained from the header to maybe the effluent treatment plant, or this fluid can be again taken back to the degrease tank. I sincerely hope you liked the presentation of our Mega Coalescer. If you have any questions or comments regarding this unit, please let us know. We will be more than happy to help you out. Thank you.